Okay. Right, so now, guys, come on. Page 98. So, finally, yes. And then we restart in January. Now, what we're going to look at now is Joshua, come on. Deal with it. Right. So just to point out, in the last class we saw the proof that gives us a way of calculating area between A and B underneath a curve. We've learned that this area here will be integration from A to B, f of x dx. But there's one requirement which I didn't say in the proof, which I'm saying now. This is only true if f of x is greater than 0. So like how I drew it in my diagram. If f of x was less than 0, if the curve was under the x-axis, it's quite easy to fix. All you do is you put a minus in front.
Yeah.
And which also is the same as switching them, yes. Now, there is one situation then that it gets complicated, and that's this situation, where it starts off as positive, but then changes to negative before the end. This is a special case which we'll look at separately. For the moment, we have this one for when it's above, and then this one here for when it's below.
So, does it supposed to be bigger or equal to this than zero?
No, I'm saying both are allowed, yes. In this situation, use this formula, and then in this situation, just put a minus in front of the formula, that's all.
Don't you switch the B and A?
Exactly, you can switch the A and the B. So you could change this to a plus and then make this a B and an A if you want. Not necessary, just if you want. Okay. So the real thing now is let's look at some examples of that. Okay, do you have those formulas? So this here, that's just a special case. These are the two formulas. And I'll also say that x is between A and B, of course, and then x is between A and B. Yeah, you don't need this here. Okay, so we'll have a look at some examples now. So the first example I want to do is an example where you already know the answer. So what I'm going to do here is we have this straight line, and the equation of this line is just f of x equals to x. So it's just a straight line. And here I'll mark off 0, and here I'll mark off 1. By the way, what would be the height here at 1? 1? Yeah, it'd be 1, yeah, which here is 1. Now, if I ask you what is this area here, you don't need any special formula because of the triangle. So what is the area here? Just as a triangle.
Base
A half the base by the height, so in this case what would it be? It'd be a half. And the reason I'm doing this as our first example is I want to show you that it does give you what you expect for the area. So let's do the formula. We integrate from 0 to 1, 0 to 1, our function. Okay, so what is the integration of x? X squared over 2. 0 to 1. That would be 1 over 2 minus 0 over 2, which equals a half. Which is what you expected. And also physics students, remember today we were doing area under the curve is the distance. you could actually use this here to calculate the area under the curve. So we'll have a look at more complicated examples now, but that's just the first example to get you started of calculating the area. So what we'll do is we'll look at a quadratic now. Yes? Scroll down? Okay, so quadratic now. No? Hurry up. So let's see. Okay. I need to scroll down now. So I'll give you this quadratic here. Oh, by the way, in the exam they usually give you the graph. So for example, I might give you a question like this, and here I say y equals x squared minus 3x plus 2. And my question might be to calculate this area. And that's all the information you know. So my question is, get this area here, calculate it. So what do I need to do first here? What's the first thing I need to do?
We need to get x bigger than smaller than 0.
Not this, no, not yet.
Y is 0 to get the
Yes. First, we have to make y 0 so we can find the roots, these points here. So we have x squared minus 3x plus 2 equals 0. That means x equals 1 or 3. Isn't it? Sorry, 1 or 2.
minus 1, minus 2.
Well, they're the factors. And then the roots would be 1 and 2. Now, if I want to calculate the area, I need to do 1 to 2, x squared minus 3x plus 2. But, because this is underneath the curve, we need a minus here. Okay. So, we can calculate now. This would be minus x cubed over 3 minus 3x squared over 2 plus 2x 2 to 1. So this would be minus, and then I put in the 2, so that would be 8 over 3, and then this is 2 squared, which is 4 over 2, which is 2 by 3 is 6, plus 4, minus, and then I put in the 1. So that's 1 over 3 minus 3 over 2 plus 2. Okay, and we type this into the calculator and see what we get. So you should type it in as well, please. Okay. And I get 1 over 6, is it? Did I? Yes, I think. 1 over 6 is the area. Yep.
Isn't that the same as doing it the normal way of changing the sign?
What do you mean?
I mean, if I do the limit from 2 to 1 without putting a negative sign.
Yes. Yes.
Then my final answer would be a negative. So I just change it.
Yes.
Positive.
Yes. 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 Yes, it's fine. Yes, whatever makes you happy. Once you get 1 over 6, I don't care. You can deal with the sign. You can deal with the sign at the start or at the end. I dealt with it at the start. You can fix it at the end. Both are fine for the exam. Okay, that's a quadratic. Now let's have a look at a cubic example. So actually, we'll get our graphing program open. Okay. Hey guys, come on. Can I scroll down? Do you have this? Okay. So cubic one, and the cubic is the most common type for the exam. I'd say 90% of the time it's a cubic one they have you do in the exam. Okay. Oops, sorry. Right, so let's go down cubic one, for example. Now, let's see. Let's take a cubic one here, if there is one. Oh, I didn't actually... Oh, there it is. Number 21. But I don't want to do that because I want to leave you with one to do. So I'll just make up my own example here. I'll take another cubic. There's
22?
no, that's actually more difficult. No, it's okay. I'll just take a cubic from a different page. Okay. Right, we'll do this cubic, for example. So I have y equals 9x cubed plus 10x squared minus 43x plus 24. And my question is, what is the area between the curve and the x-axis? Just like, if I go back for a moment, whoops, just like this one here, I wanted the area between the curve and the x-axis. Okay. Now, this has happened in the exam. Precious, don't do that. Don't do that, please. Now, hang on. No. Why are you looking around? How many Preciouses are there in this class? Don't be ridiculous. You know what I'm talking about. They aren't designed to be hung out of your nose like that. All right? So please don't be ridiculous. Next time I'll move you. Okay? Yes. Right. What do I need to do here? No, actually I will move you. So sit up here, please. So what do I need to do here? For this one, what should I do first?
Find the root of the equal to 0.
Simplify it. First you need to simplify this equation.
Simplify how?
Divide by...
Make 1 0, yes.
But
So-
you won't find, yeah, you
If I make, yes, I need to make y 0. So do you remember how to solve cubics? What do I do first?
minus 1.
Before dividing,
Guess the root.
you have to guess the root, okay? So what I'm going to do is I'm going to give everybody a couple of minutes. I want everybody to try and get the 3 roots here. Everybody? Yes. Am I going to just... Oh, you're going to tell me the first one is what? That's the factor, is it? Yeah, so if you put x is 1, do you get 0?
1, negative 3, and
Yeah.
9.
Okay, so we'll just do it one at a time. So if you put x as 1, you get 0.
Yes.
So then what's the factor? X minus 1. So now do the long division and solve the cubic. I should also point out what I'm doing is exactly like an exam question. They didn't tell you the roots in the integration question. You had to find it first as part A of the question.
So don't solve this manually, first you have to replace this decimal with 0.
First find one root by guessing.
Yeah, and then you need to multiply.
Yes. Yes, and then solve the quadratic that appears. No, I'm not confused. This is your cubic. Divide x minus 1 into it. Remember long division?
Yeah.
Yes. You didn't forget. X minus 1 divided into this. Yes, there we go.
Yeah.
Yeah, it's all coming back to
You
you.
need to do this second example to find it.
No. This, what I'm doing here was like a past exam question, where they didn't tell you the
No,
roots.
but we need to guess the root.
Yes. What you're doing now is exactly what you would have to do in the exam. have it? Yeah. So the first one was minus 1. X equals 1. And the second one, x equals, you're not finished.
8 over 9 or minus 3.
8 over 9 or
Minus 3, yeah.
minus 3. Okay, so we have our 3 roots now. So I'll just draw that. Okay, so we have, of the 3 roots, what is the smallest one? 8 over 9, isn't it?
Minus 3.
Oh, there's a minus 3? Yeah, minus 3. 8 over 9 and 1. And the cubic goes like this, doesn't it? Up, down, up. So I want this area. Yeah? No, I think this. Did I draw that the right way around, or is it down? Anyways, I know. I'll just check it here. Can you read out the cubic? What was it? 9x cubed.
Plus 10x.
Yep. Okay. Just let me reset it here. The reason it looks like it's 1 here, it's not. It's just they're really, really, really close together. Okay, so there actually is. You can't really see it here, but there actually is 2 there. But I can't. It's too close together to try and get it to show up. No. But there are 2 there. 8 over 9 and 1 are very close together, so you can't see it. But there are 2 there, so that's right. Okay. So if I want the area, that would be minus 3 to 8 over 9, 9x cubed plus 10x squared minus 43x.
We have to subtract 8 over 9 to 1.
You're right. The next part now will be minus, because it's under, 8 over 9 to 1, 9x cubed plus 10x squared minus 43x, sorry, I'm running out of space, plus 24. So that equals, so we have that one with minus 3 and 8 over 9, minus, and then we have this one, 8 over 9 and 1.
Twice, right? Once for 8 over 9.
8 over 9 goes in twice, yeah.
Yeah, and then the next step is to solve for 8 over 9 and 1.
Oh, sub them in.
No, I mean the area, you have to try 2 areas. Area 1 and area 2.
Yes, and then combine them. I'm kind of doing it all in one go here. This would be, I'll put a different colour to make it easier to read, 9x power 4 over 4 plus 10x cubed over 3 minus 43x squared over 2 plus 24x. And then here is 9 over 4, it's the same thing. Is this my one or yours?
Yes.
Okay. Now there's a lot to type here in on the calculator. A lot to type in. 9. If you think about it, in total there are 1, 2, 4 things here to calculate. This one here, what do you put x equal? Now hang on, just so you're clear, I'm not writing the whole thing out while I'm typing it in the calculator. What I do is I put x equals 8 over 9 into this, yes? And then here I put in x equals minus 3, and then I subtract them. And then in this one I put x equals 1, and then here I put x equals 8 over 9. I subtract them, and then I subtract them too. So there's an awful lot to type in on your calculator. But that's all you're doing. You're just typing in something really long on the calculator.
It's 181, 154.
You getting there? 1. Yeah, but you didn't type in your calculator's doing the integration. In the exam you need to show the whole. Oh, you will? Okay, yes.
But the answer is...
But you're getting straight to the answer is 181.
Yeah.
181 is the answer right here. Now, let me just go back to the program for a second. Come on. Guys. Now what I'll do is I'll just get the program here to solve the answer. So, first what do? I'll just type in integrate. What was my first one? It was from minus 3 to 8 over 9. That's that there, okay, and then my other one was from 8 over 9 to 1, okay, and then I did that one minus that one. Alright, so you can't see it there, but anyways, nope, sorry. Yeah, that's what we had there on this line. Anyways, I just want to get the exact answer to make sure we're right. Uh, 181. Yeah, so 181 is right. Yes, question? No? Okay, there's one last type of area problem to do. So we did line, quadratic, cubic, and now what we're going to do is the area between two curves. Okay. Can I scroll down now? Yeah. So for example, let's pick a not too difficult example. Let's say we have something like this. Oops. Y equals x squared. And then let's say we have a curve here, line here, sorry. And this one here is y equals x. And I want this area. Now this one is quite different to what we've been doing, because up until this point we've always been finding the area between the curve and the x-axis. In this situation I want to find the area between two curves. Okay? And the way we do that is not too difficult compared to what we were doing. Yeah, this is what you do. Let's call the curve on the top F, and then let's call the curve on the bottom G. If you want the area between them, let's say here is A and then here is B. It's the same, A to B, except what you put in for the integration is fx minus gx. Because if you think about it, what you're really doing is you're calculating this area here, and then you're calculating this area here, and then when you subtract them, you get the one that you want. So in other words, this is the result. When you want the area between F and G, you use that formula. This only works if F is always above G. If F goes underneath G and then back up again, you have the same problem as with the cubic. You have to split it. So here, look, when f is above g, it's that formula. But when g is above f, then what happens here? A minus, which basically means that these two swap around. In other words, always put the bigger one before the smaller one, is essentially it. So now, if I go back to my question, now it doesn't seem so difficult. In my question I gave you, what would be the f? Y equals x, yeah, x. And what would be the g? X squared. What is the a and b limits?
The intersection.
Yes, the intersection, isn't it? So you have to solve first to find where they meet. So we'll do that first. Well, you know how to solve this. This is the one linear and one quadratic. What technique do we use here? Substitution. So we get x squared equals x. That's x squared minus x equals 0. That's a quadratic. This has two answers, x equals 0 or 1. How do I get the y? I just sub it back into this one. So what would the y be? 0 or 1. So anyways, it means that this point here is 0, 0, and then this point here is 1, 1. Okay, now we can do our calculation. It's 0 to 1. F of x, the f on top, which is x, and then minus the g, which is x squared. Okay, so that is x squared over 2 minus x cubed over 3, 0, 1. So that would be 1 over 2 minus 1 over 3. Minus 0 minus 0, which is 1 over 6, isn't it? Yeah. That's a 6. Question? Yeah. It's the bigger one that goes on top, which in fact, if you look at the graph, is actually the straight line. The straight line is above the quadratic. So the choice is not a choice, actually. You must put the function that's higher first in the formula. Yeah? And the only way you can really tell that is if you had a graph to look at. So when you look at this graph, which is higher, the line or the quadratic? Well, you can see the line is first and the quadratic is underneath it. So it's always top minus the bottom one. Yeah. Now, just as a side note, if you had something like this, and you wanted this area as an example, okay? Let me just, can I scroll to the left? It's okay? Yeah. Let me call this point here A, B, and C. So how could you find A, B, and C? Well, that means you have to use substitution technique to solve, okay? So let's just say we had A, B, C, and let's call this one here F, and then we'll call the line here G. So what would be the formula for the area here? It would be A to B, Fx minus Gx, and then minus B to C, Fx minus G. No, you see, just be careful, okay? The problem in the second case is that the function has flipped. Okay, so let me be really clear here. I said we put the upper on first and the lower one second. Yeah, but the problem is we're in the middle of the line. We're in the middle of the equation. It's not like It's not like this is a separate problem, you know, it's still on the same line. At the start, I call F upper and G lower, yes? I should stick with that for the rest of the line, otherwise I'll mess it up. Okay? You might say, but this is wrong, because the upper one should be on the top. I know it's wrong. This is how I fixed it, by putting the minus there. This fixes it. Now, yes, but if you remember from the first lesson, how can we get rid of the minus? If I change this to a plus, then it means I change the limits. Okay? Now, look, it can get very messy, and I'm trying to simplify it, all right? At the start of the question, you make a decision. What is the upper and what is the lower? So at the start, what I call my upper function, F, and my lower one, G. I must stick with that for the rest of the question. But if they swap places during the question, the way I fix that is by putting a minus in front of that part. Okay? So at the beginning you make a choice. What are you calling the upper function? What do you call the lower function? You stick with that choice until the end. And then, as you're doing it, it swaps underneath. Just like with the cubic going under the x-axis, you put in a minus and fix it. It's just like in physics. You make a choice at the start with the G, if you call it positive or negative, depending on what you're measuring is up or down. But you must stick with that choice until the end of the question. I'm saying it's kind of the same idea here. I'm calling F the upper, G the lower, I'm sticking with that, and if they swap, I change the sign. But I don't swap the F and the G, or mess with the limits. It just gets messy. Okay. Now, I've seen this type of question once in the exam. Once, okay? So it has come up in the exam. But it's not so common because it's kind of difficult. But it could come up. It's not impossible. Okay? Right, now I want you to try some of these. Basically in the exam, question 6 is usually integration. Number 1, 1, 2, 3. 1, 2, 3, 4. Yeah, the first 4 and the last 4. 1, 2, 3, 4, and then 8, 19, 20, 21, 22. First 4 and last 4. Wait. No, I don't like this sound of people packing up at the start of the class when I haven't said we're finished. Don't just, you two, just be still. Now, next week, we'll look at past exams. It would be really, really good for your own study and revision if you print out the book. It's easier than trying to read it on your phone. Okay? So on Monday, try to bring a printed version of the book. Okay? It's not, it's 57 pages, but you could print it 2 per page, double-sided as well. So that if you did double-sided, it'd only be 26 pages. And then 2 per... Well, this is... Yeah, 57 pages, but that's counting both sides. So 20... You could probably print it on about 13 sheets of paper. 14 sheets of paper. 14 sheets of paper will get you to 56. Yes, you need 1 extra page. 15 sheets of paper will print out this. How much is the printer card?
14 sheets, and its printer card is 2 something.
How many pages can you print?
Sure, 3 current price.
How many copies?
Is it better?
So 1 printer card would be enough for all of this. Yes?
Correct.
But you know, if you have the penalty system,
Now, hang on. No, don't complicate things. Just answer me this. When you print something, do they charge you for double-sided?
no, they tell for the paper.
For the paper. And how many pages can you print on one card?
50.
50. 50. 50. I'm saying you will use up 15 if you print 2 per page and double-sided. Alright? Even if you don't do this, you'll still have enough of one card. Okay? So it shouldn't use up too much of your paper. Alright?
When we finish.
Now hang on, I need to take the attendance before you go, okay?
Yes, 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 yes.